Welcome to our Chem 152 video series. In this video, we'll do a second example of how to find pH, this time using a weak base instead of a weak acid. We are given that CH3 and H2 is a weak base, and the Kb value is 4.5 times 10 to the negative 4. Again, we are given a 1 molarity solution, and now we'll find the pH. In order to get started, let's react this base with water. We'll start with CH3 and H2 plus water. We'll use a double arrow to show that it is a weak base. Therefore, water will act as our weak acid. Our weak base will gain an H and go more positive. This will change our weak base to CH3NH3 positive. Our acid must lose one of its H's, and now it will be OH, and it will go more negative for a negative charge. We know that our initial molarity for this base is 1 molarity. We are not given an initial molarity for either one of the products, so they will start at 0. We don't know how much this will change by, so we'll say our reactant will go down a little, we'll say minus X. Our products will go up a little, giving us plus X for both. At equilibrium, we will either add or subtract, giving us 1 minus X for our weak base, and X for both of our products. In a previous example, we used the small x approximation to simplify our math a little bit. However, this time, our Kb is above 1 times 10 to the negative 4th. This means that the small x approximation may be a little bit inaccurate. To minimize any inaccuracies, we'll do a little bit more math and try to find x by using a quadratic equation. Let's try to organize the algebra a little bit. Our k value that we were given is 4.5 times 10 to the negative 4th power. This will equal the products divided by the reactants. Our products are x times x. This gives us x squared on top, and 1 minus x for our reactant on the bottom. Now this equation is not in standard quadratic form, so we'll need to do some algebra and reorganize it. Our first move will to take the binomial 1 minus x on the bottom and move it over to the left side by multiplying. We'll end up with 4.5 times 10 to the negative 4th power times 1 minus x equals x squared. Then we will distribute this 4.5 times 10 to the negative 4th to both terms inside the parentheses. When we distribute, we'll end up with 4.5 times 10 to the negative 4th times 1, which is simply 4.5 times 10 to the negative 4th, minus 4.5 times 10 to the negative 4th x equals x squared. Then we'll take all of the terms that are on the left and move them over to the right. This 4.5 times 10 to the negative 4th x has a negative sign, so when we move it, we will add that to the right side. This other constant term, 4.5 times 10 to the negative 4th without the x, is positive, so when we move it, we will subtract. When we finish, we'll end up with 0 on the left equals x squared plus 4.5 times 10 to the negative 4th x, which we added, and minus 4.5 times 10 to the negative 4th, which we subtracted. This will be our quadratic equation. In a previous video about equilibrium, I went through the process of using this quadratic equation with the quadratic formula to solve for x by hand. In this video, I'll show you how to solve this using a graphing utility online. Here I've gone to desmos.com/calculator, and we can enter our equation into Desmos and then find where the graph we end up with crosses the x-axis. We'll enter y equals x to the second power plus 4.5 times 10 to the negative 4th times x. Notice that I am not using exponential notation in Desmos. If you use an uppercase E in Desmos, Desmos will not know what to do with that, so we'll enter the entire expression manually without the uppercase E abbreviation. Then we subtract 4.5 times 10 to the negative fourth. In order to see our answer on this graph, we'll have to zoom in considerably, so we'll press up on the mouse wheel. If you zoom in far enough, you can see that the graph intersects the x-axis in two positions. We click on those positions with our mouse, and this will give us our two answers to the quadratic equation. I'll copy them over to my slideshow. And we can see that our two answers are negative 0.02144 and 0.02099. However, there is no such thing as negative concentration, and so this negative answer is a false answer. Typically, if you're in a position where a negative answer makes sense, it means there was an error in your earlier setup. Our correct answer will be x equals 0.02099, which I'll round to 0.021. This will be our x in molarity. So now we know that our molarity of our weak base at the end will be 1 minus 0.021, and our molarity of our conjugate acid will be 0.021 molarity, and OH negative will be 0.021 molarity. Now to find the pH, we have two options. pH either equals negative log of H3O, or pH can equal 14 plus log of OH. Because we have OH as one of our products, we will use the second option. Our 0.021 will go in the OH position. Therefore, our pH will equal 14 plus log of 0.021. You can enter this into a calculator. If you do so, your answer will be 12.32. This will be your pH for this solution of weak base. Thank you for watching, and we'll see you again soon.